These are the activities for lesson 6. We can see that we have a linear equation graphed below. The first question asks us to find the slope of the line. To find a slope, we need to have 2 points, and you can pick any 2 points on your graph. The first point that I've picked is 2, 180. The second point is 1460. Now that I have my 2 points, I'm able to compute the slope of a line using a formula. And the slope of this line will be 120 over negative 12, which comes out to be a negative 10. The next question asks us, what is the vertical intercept of the line? So the vertical intercept is the point circled above, and that point's coordinates are 0 to 100. The vertical intercept is where the line intersects the vertical axes. Next, we're asked to give the equation of the line. We're going to do this in y equals mx plus b form. So we're going to y equals the slope, which is negative 10, x plus the intercept, 200. And finally, it asks us to describe in words a situation that could correspond to this equation. So there's many examples. One example would be that you had $200 in a bank account and you spent $10 each week. The $200 would represent the initial amount, and the $10 of spending per week is the slope. After 20 weeks, you'd have $0 in the bank account. So you can see then in our example, our axes would be labeled with weeks as a horizontal axis and dollars as our vertical axes. The next question says, pediatric growth charts suggest a linear relationship between age in years and median height in inches for children between the ages of 2 and 12 years. 2-year-olds have a median height of 35 inches. 12-year-olds have a median height of 60 inches. Let x represent the age in years and y represent the median height in inches. We're going to translate this into 2 points. So our points are going to have age, height. So our first point will be 2, 35. The second will represent the 12-year-old with the height of 60 inches. Find the average rate of change of height with respect to age. This is the same thing as asking for slope. So we have 2 points. We're going to use our slope equation to calculate the slope. Then we can interpret our results. So our slope comes out to be 25 over 10, which is the same as 2.5. And our units would be in inches per year. So now we can interpret this with a sentence. On average, a girl grows 2.5 inches each year. Now we're going to find a line for a line that models this data. So we're going to use our standard y equals mx plus b form. We have already found our slope, so y equals 2.5x plus b, and now we want to find b. So now we're going to plug in one of our points, y equals 60, and we'll put the 12 in for x, and solve for b. So we find that 60 equals 30 plus b, subtract 30 from both sides, and we get b equals 30. And now we're going to put all of it together. We're going to have y equals our slope, 2.5x, plus the intercept, 30. We're going to use this equation to predict the median height of an 8-year-old. That means that we're going to have an x of x equal 8, and we're going to solve for y. So we plug in our 8 for x. Y will equal 20 plus 30. So y is equal to 50. So an 8-year-old on average will be 50 inches tall. In question 3, we're asked to write the linear equation 2x plus 5y equals 10 in slope-intercept form. So slope-intercept form is our y equals mx plus b form. Notice that the y is all by itself. So what we're going to do is work with our equation, 2x plus 5y equals 10, to get y by itself. The first step will be to move the 2x over to the other side. So we're going to subtract 2x from both sides, and we get 5y equals 10 minus 2x. Next, we need to divide this equation by 5. So we're going to divide the left side by 5, and then each of the terms in the right side by 5. Cleaning this up, we get y equals 2 minus 2/5 x. And we can rewrite that where we have negative 2/5 x plus 2, and that's really putting it in slope-intercept form. Our negative 2/5 is our slope, and 2 is our intercept. We're able to read off both the slope and intercept once we've rewritten the equation. So number 4 says that in 1999 there are approximately 100 million internet users in the United States, and this number grew to 200 million in 2005. We're going to let x equals 0. So in other words, in 1999, we're going to say let that be times 0. We're going to call that 0, and there's 100 million internet users. The other time we're given is 2005. That's 6 years after 1999. So 6 years later, we now have 200 million internet users. So again, we're going to find an equation for a line that models this data. We're going to use our y equals mx plus b. So we're going to first find our slope, m, using our equation for slope. We have 200 million minus 100 million over 6 minus 0. So we have 100 million over 6. This fraction can be simplified to be 50 million over 3. Or we can do the division. We get 16,666,667 rounded. Next, we're going to want to find our intercept. So we plug in our slope. We have y equals 16,666,667 x plus b. And we can plug in a point. We're going to plug in 0, 100 million. And we find that b is equal to 100 million. So we were actually given the intercept, the y-intercept from the beginning. So putting it all together, we now will write it in slope-intercept form with our slope times x plus our intercept. And the next question asks us to interpret m as a rate of change. So interpret the slope. On average, the number of internet users grew by 16,666,667 each year. And the last question asked us to estimate the number of internet users in 2008. 2008 is 9 years after 1999. So our x will equal 9. We'll use the equation that we found in part B and plug in 9 for x and find out the number of users that we expect. So y is equal to 250 million internet users.